So here we have another question involving rates of change. It starts off by saying the volume of hemisphere v centimeter cubed is related to its radius r by this equation. So I'll write down the equation first. V is equal to 2 over 3 pi r cubed. And since we've got an equation involving v and r, potentially what I could go and do is I can work out what dv by dr is, because v and r are my variables. So I'll differentiate v with respect to r. It doesn't tell me, but that's the first thing that I read on that line. And if I do line by line maths here, if I differentiate that with respect to r, the two variables, I can get another differential, which I can then use later in the chain rule. So let's go and differentiate this. So I'm going to have 3 lots of 2 over 3 pi r squared. Simplify this, that gets me 2 pi r squared. So this is what my dv by dr is. I'll keep that to the side. That was just looking at that first line. Then it goes on to say the total surface area S is given by this equation here. So they've given us an equation. I'll go and write that down. S is equal to 3 pi r squared. Again, for this hemisphere, S is a variable, the surface area, because it changes with r. So like before, we can also differentiate S with respect to r. So I can find another derivative here, ds by dr, which is equal to, again, differentiating with respect to r, so it will become 6 pi r in this case. So I've done the first line, tick. I've looked at the second part, tick that, I found the differential for that. Okay, so let's go and see what it then goes on to say. Given that the rate of increase of volume in centimeter cubed per second. Now, when you look at the units, you can actually figure out what it's referring to. Centimeter cubed means volume. Per second means per unit of time. So we can see that this is dv by dt, which makes sense because that's what they've said here. dv by dt is equal to 6 centimeter cubed per second. That unit is associated with that differential there, or this rate of change here. So I'll go and write that down here. dv by dt is equal to 6. So straight away here I can see I've got a few differentials here. dv by dt, I've got ds by dr, I've got dv by dr, and I need to somehow connect these. Okay, so notice how I approach this. I used line by line maths, went on, did the maths as I went along, found some derivatives for each of those equations that they've given us, and then I'm focusing on the last bit where it says find the rate of increase of surface. Rate means something changing with time. Increase of surface meaning we're looking at the rate of change of the surface area, which is ds by dt. Sometimes they will only give you the wording, they won't actually write down ds by dt, and you need to figure that out by understanding the word rate, as I've explained. So let's go and write down what we're after. We're after ds by dt. That's what we want to find. Now, how can we find out what ds by dt is using all the equations that we have? Well, notice my starting point. I'm always going to look for what's on my numerator, ds. Do I have a differential from one of those? I'll label them number 1, number 2, and number 3. Do I have one which has ds in it? As we can see clearly, number 2 has ds in it, so I'm going to go and write that down first. ds by dr. And this is the approach that you should take here. So now I've got my ds there. Now I'm going to look for something that has dr on the numerator, because the reason for that is I want to get rid of this r. I don't want r at all in my differential, because I want to end up with something which just simplifies to ds by dt on the right hand side. So I'm going to look for something that has dr on the in the differential to begin with, one that I haven't used. I've already used number 2, tick that off. I can see there's only one, not number 3, that doesn't have any dr in it. Number 1 has dr in it, but can you see the dr is on the denominator, but I want the dr to be on the numerator, so it would have cancelled out. So all I'm going to do is I'm going to write this number 1 here, but I'm going to do the reciprocal. I'm going to write down as dr by dv. Okay, notice how my drs would cancel out. Okay, that's the idea. I'm not going to cancel it out. This is just showing you for the purpose what I'm trying to do. I'm trying to get my drs to cancel out, and that's how I know to do the reciprocal. And that's how I know which differential to pick. So I've picked that one appropriately. Let's get rid of the cancelling. We know it cancels. But if it did cancel, can you see I still get a dv on the denominator? I don't want there to be a dv. So I need to go and now look for something that has dv on the numerator, because if I can write something with dv on the numerator, my dv's will cancel. So do I have an equation that involves dv? Yeah, I've already used number 1, tick that off. I can see there's one here, number 3, which has dv on the top already. It will be dv by dt. As you can see here, the dv's cancel, leaving us on the right hand side with ds by dt, which is exactly what we have on the left hand side. ds by dt, and on the right hand side everything simplifies to ds by dt. So now I've used the chain rule correctly, and that's always how you should check. Have I multiplied the correct derivatives? Have I written them the right way around? Do I need to do the reciprocal one of them? And a quick check is check if everything cancels, dr cancels, dv cancels, leaving you with ds by dt. And that's a way of checking if it's correct. So now my chain rule is correct. Chain rule applied correctly here. Chain rule, that's my check. Chain rule applied correctly and checked. Okay, now obviously now we want to go and substitute things that we already know. So what is ds by dr? Well, let's take a look at number 2. ds by dr was 6 pi r. So now I'm going to do the substitution, 6 pi r. There's nothing next to them, so we're multiplying. So that's going to then times with what is dr by dv. Well, dr by dv, as you know, it's number 1 here, but it was the reciprocal of it. So it will be 1 over 2 pi r squared. Times by what is my dv by dt? dv by dt was 6. Notice here I've got some fractions and I've got some whole numbers. So let's make it a bit tidier. To deal with that, just write it over 1 over 1. It just makes the maths a bit easier to see. We're only multiplying numerators with numerators, denominators with denominators. So we end up with 36 pi r over 2 pi r squared. Simplifying this, so we've got divide by pi on the numerator and denominator, and divide by 2 on the numerator and denominator results in 18, and divide by r on the numerator and denominator results in that happening. So we end up with 18 over r. That simplifies to. Okay, so that is what ds by dt is. ds by dt is equal to 18 over r. Let's go and check if we've answered the question. The question says find the rate of increase of the surface area, ds by dt. We have found that it's 18 over r. We don't know what r is. If we did know what r is, then we can find out the rate for that particular case.